look at logarithm. Logarithm, we are still talking about the powers of numbers. If, for instance, we have 1000, which is the same thing as 10 raised to the power 3. We have 100, which is 10 raised to the power 2. 10 as 10 raised to the power 1. And 1 as 10 raised to the power 0. Now, here we establish that the power is called index or indices, and it's also called logarithm. So, in another way, I could say log 1000 base 10. What am I saying? I'm saying we are looking for the power of 1000 when it is taken to base 10. That is, what will be the power of 10 when we want to express that 1000? That will give us what? 3. We have it here already. So this will give you 3. Invariably, we can say log 100 taken to base 10. We have it here. When it's taken to base 10, it is what? The power is 2. So the log of 100 base 10 is 2. Also, the log of 10 when it's taken to base 10 is what? 1. Also, log 1 taken to base 10 will give us what? 0. So this is the relationship we have between indices and logarithm. Let's use a general formula. Give, for instance, we have m equals to a raised to the power x. So this will be the same thing as saying log m when it's taken to the base. We remember we said base is what carries the power. Taken to base a. What is the power? The power is what? X. In fact, this is one of the laws of logarithm. But let's look at the laws of logarithm expressly. The first one, which is called the product law. If we have log mn base a, this is the same thing as m taken to the base a plus log m base a. For example, we have log 6. Let me establish something I didn't say earlier. Whenever we have a log, give for instance log 6 here. This log 6 has a base of base 10. Base 10 is not necessarily written, but other bases are written. Give for instance log 6 base 3. The 3 will be written down here. If it's base 2, it will be written down there. But base 10 is not necessarily written. So this log 6 is in base 10. So log 6 is the same thing as log 2 times 3. And by the law, we said when they are multiplying each other like this, this is the same thing as log 2 plus log 3. Second law, we have log m over n dividing each other. This will give us log m minus base a log n base a. For example, if we have log 5, log 5 is the same thing as log 10 all over 2. Now we separate each one of them like the law by putting a minus sign. So this will be log 10 minus log 2. Let's look at the third law. For the third law, we have log m raised to power p base a. If we have the power comes over to the front to become a coefficient to the log, so it becomes p log m base a. Give for instance, if we have log 2 raised to power 3, this will be the same thing as 3 log 2. The power coming over to the front. Let's look at a fourth law. If we have log a base a, that is, the number is the same as the base, this will give us 1. Give, for instance, you have log 2 base 2. This is the same thing as 1. In fact, when you come over here, you can see that log 10 base 10, that is the number and the base are the same. So it gives us what? 1. Let's look at another law. Fifth law. If we have log 1 base a, log 1 base a is what? 0. If we come over to this side, you will see that log 1 base 10 is what? 0. So no matter the base, if it is log 1, no matter the base 9, base 2, it will give you what? 0. Let's look at a sixth law. If we have log m base a, it's the same thing as log m base b all over log a base b. That is, a difference or another base has been introduced. Give, for instance, if we have log 4 base 2, or rather log 2 base 4, we can say that this is the same thing, introducing a base of 2. The initial base is 4. We are putting another base. So this will be log 2 base 2, the new base, log the base here 4, but putting the new base 2. From our fourth law, we know that when the base is the same, it's 1. So this will give us 1. And for this one, we know that 4 is the same thing as raised to the power 2. So this is log 2 raised to the power 2 is 2. The 2 will come to the front. It becomes 1 over 2 log 2 base 2. This one will now become 1. And this is 1 all over 2. But there is an alternative method to make work easier and faster, peradventure in your JAMB examination. Still looking at the example we have up there, an alternative method. Log 2 base 4. What we can do is, when we have something like this, I want to simplify it faster, instead of just changing the base or introducing a new base, like the method up here or the law up there. What we do is, we take this to the base, the number at first. This will give us log 2 raised to the power 1. Then the base, we also take it to the same base of the number, which will be 4 is the same thing as 2 raised to the power 2. So this base and this base will cancel out, and this will give us 1 all over 2. Let me give you another example. If you have log, let's say 27 base 9. The same way, this is the same thing as simplifying. This is say 27 is the same thing as 3 raised to the power 3. And 9 is the same thing as 3 raised to the power 2. So the base, 2 base will cancel, and we have 3 all over 2. To make it easier and faster. So these are the laws of logarithm. Let's solve some questions from our JAMB past question. Number 1, if log 18 base 3 plus log 3 base 3 minus log x base 3 equals to 3, find x. Taken from 2011 JAMB. So number 1, we have log 18 base 3 plus log 3 base 3 minus log x base 3 equals to 3. Recall that when we have log mn base 8 is equals to log m plus log n base 8. So that means that if we have addition, it can be taken to multiplication. Then also the second law, which is log m all over n base a is equals to log m minus base a minus log n base a. So that means for this one it will multiply and this one will divide. So we have from the question we have log 18 multiplied by 3 divided by x all base 3 equals to 3. When we multiply this we have log 54 all over x base 3 equals to 3. From our relationship between indices and logarithm, we said that when we have m equals to a raised to power x, log m base a will now be x. So that means that since we have the number, this representing the number, we have a base, we have this, we can take this vice versa to an index form. So our question will now be 54 over x equal to 3, the base raised to power, the power here, so that will be 3. So now this will now be 54 all over x equals to 27. Cross multiply, we have x equals to 54 over 27. The 9 will go here 3, 9 will go here 6, 3 will go here 1, 3 will go here 2. So x is equals to 2. So that is how we answer question 1. Let's go over to question 2. It says, given that log 2 is equal to 0.3010 and log 7 is equal to 0.8451, evaluate log 112. Now look at it, question 2, log 112, we are evaluating this. Log 112 is the same thing as log 7 times 8 times 2. Right? So if we multiply this, we have log 7 times 16. So it now give us log 7 times 2 raised to power 4. Now from our question, we have been given the values of log 2 and log 7. So we put it into that expression. But first of all, let's separate it. That is log 7, using our first law, will be log 7 plus log 2 raised to power 4. We have log 7 plus this, by the third law, we come to the front, so it will be 4 log 2. Log 7 from our question is 0.8451 plus 4 bracket log 2 is 0.3010. So this will give us 0.8451 plus, we multiply this, 4 times 0 is 0, 4 times 1, 4, 0, 12, 2 carry 1, 0 plus 1, we have that. Then we add the two numbers. So this will be equals to 1 plus 0 is 1, 5 plus 4, 9, plus 0, 4, 8 plus 2, 10, carry 1, 0 plus 1, 1, plus the 1, that will be 2 points. That. So our answer for question 2 is 2.0491. Let's go over to question number 3. It says, if log 64 base x raised to power half equals to 3, find the value of x. 2008 question. So let's go into it. Log 64 base x raised to power half equal to 3. We want to find the value of x. Now you can see that the base has a power itself. So to solve this, we go over to the law with the relationship with indices, that is m equals to a raised to power x, and so that will be log m base a rather is equals to x. So since we have a log here, we can change this expression to index form. So to change this, we have this base coming up to take this power. So it will be 64 equals to x raised to power half raised to power 3. So this will now give us, when we have this in indices, we know that we multiply both powers. So this will be x raised to power 3 times 1, that will be 3 all over 2 equals to 64. Now, for us to solve this, we can multiply the reciprocal of the power, that is 2 over 3. So we multiply both sides by the reciprocal of the power. The reciprocal of the power will be 64 raised to power 2 over 3, and the other side will be x raised to power 3 over 2 multiplied by 2 over 3. So by the time we cancel that, we have x equals to. Now for this side, we have 2 over 3. Remember that the numerator is the power and the denominator the root. So we have root 364 all raised to power 2. What will multiply 3 times to have 64? We know it is 4. Then raised to power 2. So x will now be equals to 16. That is 4 times 4. So that's how we solve question number 3. I believe with the explanations and the questions we've solved, you'll be able to answer questions on indices and logarithm.